So for standard 5, we're given a 12 centimeter long segment that makes a 72-degree angle with a 16 centimeter long segment. So 16, 72. So then part A is asking us to the nearest tenth of a centimeter, find the third side of the triangle determined by this SAS information. So with this problem was introduced to us before we found out what the law of cosines was, which would just make this a lot easier. But we can still manage to solve this side without the law of cosines. And so you can start by finding out the altitude right here, which would be y. Well, actually, I'll just call that h. H equals sine 72 times 16, because opposite hypotenuse, and then 16 is the hypotenuse. So that would equal to h equals 15, which we now know. And so then we can find the base of this new triangle, which I'll just call x, and this is 12 minus x, which would be x equals cosine 72 times 16, because 72, cosine 72 is adjacent hypotenuse, and hypotenuse is 16, which would mean that x is 5, and so that's 5, and the base for that other triangle is 7. And so now we can start to find this with Pythagorean's theorem, which is 15 squared plus 7 squared equals c squared, and solve that out. C equals 16.6. That's for part A. So for part B, we're asked to find the area of the triangle. Again, we weren't given law of cosines and the area incorporating cosines, but we can still find it by finding the area of each of these triangles and add them together. And so area equals 5 times 15 over 2, which is this triangle, plus 7 times 15 over 2, which is this triangle, which would make that 15 plus 52.5, and area is 67.5 centimeters squared. I'll put that in. Okay, that's it.